The U7, positioned as BYD's flagship model, focuses on multidimensional mobility and intelligent adaptability rather than relying solely on sheer acceleration or minimalist aesthetics. This vehicle represents a significant shift in Chinese innovation within the luxury electric vehicle market, a space historically dominated by Western brands that prioritize strong branding but offer relatively incremental technical advancements. BYD's strategy highlights practical innovation and mobility intelligence over traditional luxury markers such as premium interiors or established brand prestige. Importantly, these features are production-ready rather than just experimental concepts, making the U7 a notably disruptive entrant. This could signal a broader trend toward valuing function-driven luxury over conventional status symbols in the automotive industry. BYD's launch of the Yangwang U7 boldly signals its ambition to not only compete with but potentially surpass established luxury electric vehicle brands. While the vehicle's performance in international markets remains uncertain, especially amid ongoing trade tensions and regulatory challenges, the release of the U7 clearly reflects BYD's forward-thinking strategy. More than just another premium EV, the U7 represents the pinnacle of BYD's technological innovation and offers a glimpse into the future of luxury mobility. In this future, software integration, autonomous features, and adaptability will redefine what it means to be truly premium. Within this evolving landscape, BYD's visionary approach could very well establish a new industry standard. Central to BYD's most advanced models is the revolutionary E-platform, a four-motor independent drive system that reimagines electric vehicle dynamics. Unlike traditional configurations that use one or two motors, this system equips each wheel with its own motor, enabling fully independent torque vectoring. This design delivers unmatched precision in power distribution, balance, and responsiveness. The emphasis is not merely on raw speed, but on refined, intelligent control of every movement, essentially mastering motion itself. Beyond theoretical advantages, the E-platform has demonstrated its real-world capabilities, notably excelling in moose tests designed to evaluate high-speed obstacle avoidance. Vehicles utilizing this platform have reached an impressive top speed of 95.78 km per hour, showcasing exceptional agility and safety. The system also supports advanced maneuvers, including automated in-place U-turns without the need for gear shifts or braking, as well as lateral movements that allow the car to slide sideways out of tight spaces with as little as 30 centimeters of clearance. Equipped with multiple driving modes tailored for different environments, the platform offers options such as a big stride mode for rapid lateral repositioning and a small step mode for precise control in crowded or compact urban settings, making it ideal for city driving and parking. In terms of safety and fault tolerance, the E-platform is engineered for true resilience, not just redundancy. If a tire blowout occurs, the remaining motors dynamically redistribute torque to maintain vehicle stability, even during diagonal blowouts, at speeds up to 160 km per hour. This adaptive control ensures the vehicle remains operational in situations that would typically disable conventional cars. Enhanced by intelligent systems, distributed control, and advanced fault isolation, the E-platform redefines expectations for high-performance electric drivetrains. It also features fail-operational capabilities, enabling the vehicle to safely complete its journey even if one or more drive components fail, an essential attribute for autonomous and semi-autonomous driving systems. What sets the E-platform apart is its remarkable scalability. It is not confined to a single luxury model but is designed to be adapted across BYD's entire lineup, ranging from flagship vehicles like the U7 to upcoming mass-market cars. This platform seamlessly integrates with BYD's advanced systems, including the Yun-Nian Z suspension and the Magic Ruler sensor suite, forming a tightly connected network for feedback and control. As the automotive industry transitions from traditional mechanical systems to software-defined vehicles, BYD's E-platform represents a transformative design philosophy where motion becomes programmable, precision-driven, and deeply intelligent. The key question is no longer whether this technology is effective, but how quickly the rest of the industry can catch up. Central to BYD's mission to revolutionize ride comfort and vehicle stability is the Yun-Nian Z system, an intelligent suspension and body control technology inspired by magnetic levitation principles. Developed over 7 years by a team of more than 10,000 engineers, this breakthrough marks a fundamental change in how vehicles interact with the road. Unlike conventional mechanical suspensions, Yun-Nian Z uses direct drive suspension motors to manage vertical movement with extraordinary speed and precision, delivering a maglev-like smoothness in passenger cars. Its standout capability is an industry-leading 5 millisecond response time, enabling up to 12 suspension adjustments while traversing a single speed bump at 30 km per hour. Yun-Nian ZS far exceeds the typical 0.5mm adjustments common in conventional active suspension systems, achieving an impressive height adjustment precision of 1mm. This allows it to perform complex motion tasks such as drawing characters with the car's chassis or executing synchronized, robotic-like movements. Beyond impressive demonstrations, Yun-Nian ZS delivers a driving experience characterized by zero bounce, zero pitch, and zero roll, even on uneven terrain. Crucially, the system integrates adaptive safety features that dynamically respond to road conditions and potential collisions. For instance, in the event of a side impact, the suspension can instantly lift one side of the vehicle to redirect crash forces toward stronger structural zones, significantly reducing the risk of injury. It also manages advanced maneuvers like climbing curbs or descending stairs with minimal vibration, thanks to real-time load sensing and force redistribution. This level of integration between suspension and safety systems is unprecedented and unmatched by traditional chassis platforms. What truly distinguishes Yun-Nian ZS is its innovative approach to suspension, not as a passive or merely reactive component, but as an active, intelligent layer within the vehicle's ecosystem. As the automotive industry shifts toward software-defined vehicles and real-time adaptability, BYD offers a compelling vision of what ride quality can become in the era of electric mobility. The advent of BYD's innovative technology may signal a significant shift away from traditional shock absorbers and springs toward intelligent, motor-driven suspension systems. If this technology consistently performs well across different models and markets, it could mark a pivotal moment for the automotive industry. At the core of this transformation is a small but revolutionary component known as the magic ruler sensor. This highly precise displacement sensor, integral to BYD's intelligent suspension and body control system, employs 3D Hall effect technology to monitor a vehicle's posture and vertical movement with exceptional accuracy. Capable of capturing vehicle motion 4,000 times per second, operating at intervals as fast as 50 microseconds, it functions 20 times faster than most conventional sensors. Its ultrafine resolution of just 15 microns, smaller than a human hair or even a red blood cell, allows for a level of responsiveness akin to surgical precision. This high-resolution feedback underpins BYD's advanced systems, such as the Yun-Nian Z, enabling vehicles to adapt instantly to changing road conditions, suspension travel, and body pitch. Beyond enhancing comfort and dynamic performance, the magic ruler sensor holds significant promise for autonomous driving and real-time AI decision-making, where the speed and granularity of data collection are critical to safety. Its ability to detect even the smallest changes in chassis posture positions it as a cornerstone technology for the future of intelligent vehicles. By continuously analyzing road gradients thousands of times per second, the system can instantly adjust torque, suspension stiffness, and braking without relying solely on predictive models. This real-time feedback loop between sensing and action enables a level of control and responsiveness rarely seen in mainstream production vehicles. As BYD expands its advanced driving systems and Level 3 redundancy architecture throughout its lineup, one subtle but crucial element, known as the magic ruler, may become the unsung hero behind many of the brand's smartest features. This innovation raises a broader question for the automotive industry. Could ultra-high-resolution sensing be the key to achieving safe, human-like driving behavior in autonomous vehicles? While technologies like LiDAR and radar often dominate discussions around autonomy, BYD's emphasis on precise micro-level vertical sensing signals a shift toward a new frontier, where the most intelligent vehicles are also the most physically aware of their surroundings. As the industry moves closer to true vehicle autonomy, redundancy has become a foundational safety pillar, and BYD leads the way. The Yangwang U7 represents a major milestone as the world's first mass-produced car with full Level 3 redundancy across 4 essential systems: steering, braking, driving, and power. In an era where a single software glitch or component failure can have disastrous consequences, BYD's robust architecture is engineered to ensure safety and reliability. To ensure that core vehicle functionality remains intact even in the event of a failure, BYD has implemented a critical fail-safe approach essential for achieving fully autonomous driving. At the heart of this safety strategy is BYD's God's Eye Intelligent Sensing Suite, which is available even on non-premium models. This system features 3 laser units powered by dual NVIDIA Orin X chips, delivering a combined processing capability of 508 TOPS. It operates in conjunction with 32 high-performance sensors, including LiDAR units with a 128 line-point cloud resolution and a detection range of up to 200 meters, providing an exceptionally detailed panoramic view of the vehicle's surroundings. This advanced perception system not only rivals but sometimes surpasses those found in many of the world's leading electric vehicles. BYD demonstrated the prowess of these systems notably during the autonomous Moose test, where the Yangwang U7 maintained remarkable stability at speeds exceeding 95 km/h while performing extreme evasive maneuvers. This level of control, evident in tight slalom courses and sudden obstacle avoidance, is a testament to more than just robust design. It stems from intelligent torque and brake redistribution enabled by the E4 platform and L3 safety stack. In cases of steering or brake failure, the system can retain control by leveraging the vehicle's independent motors and redundant power supplies, ensuring safety until the vehicle comes to a complete stop. What truly distinguishes BYD? BYD stands out with its nationwide rollout of urban autonomous navigation, offering features that are immediately available at delivery, unlike competitors who often restrict such capabilities behind subscription plans or regional limitations. While regulatory bodies continue to define full autonomy standards, BYD's hardware and software are already designed to meet the requirements for a Level 3 autonomous future. As urban environments become increasingly congested and driving conditions more complex, BYD's focus on comprehensive redundancy may establish a new global benchmark for intelligent safety systems, potentially forcing other automakers to play catch-up. In a similarly groundbreaking move, BYD recently introduced an electric motor that spins at an impressive 30,511 RPM, making it one of the fastest mass-produced motors in the automotive industry. Delivering 580 kilowatts of power per module, this motor surpasses expectations not only in performance but also in its placement within BYD's mid-tier Han L sedan and Tang L's models, rather than in exclusive hypercars. To put this achievement into perspective, it outperforms the Xiaomi SU7 Ultra's 27,200 RPM motor and the Tesla Model S Plaid's 20,000 RPM motor, both engineered for high-performance vehicles. BYD's engineering excellence is evident in the motor's use of N50H high-energy magnets, which enhance magnetic performance by 18%, and its innovative 10-layer short-distance winding design, which helps reduce copper losses. BYD's motor design incorporates a 0.2 mm ultra-thin silicon steel sheet to minimize iron loss and features direct refrigerant cooling, enhancing overall efficiency. The company has optimized the motor not only for peak performance but also for long-lasting, efficient power delivery. Precision in dynamic balancing has been refined to just 50 mg, half the industry standard, further improving stability and safety at high speeds. The motor integrates BYD's advanced 1500V silicon carbide power module, which allows for higher voltage tolerance and improved thermal efficiency, both essential for superior high-speed performance and durability. What stands out most is BYD's decision to introduce this powerful drivetrain in family-oriented models. The Han L accelerates from 0 to 100 km/h in just 2.7 seconds, while the Tang L Sub reaches the same speed in 3.6 seconds, times typically associated with exotic sports cars. Even more impressive are the acceleration times from 100 to 200 km/h, 4.74 seconds for the Han LS and 6.19 seconds for the Tang LS, rivaling dedicated track vehicles. While this advancement significantly boosts BYD's technical reputation, it has also sparked debate online. Some question whether such speeds are appropriate for everyday drivers, raising safety concerns, especially for those accustomed to conventional vehicles like the Honda CR-V, and whether they can safely handle such high-performance cars. Comparisons are being drawn between BYD's strategy and Xiaomi's, as both require users to unlock high-speed modes through practice trials. This raises the question of whether BYD will follow a similar path. The debate surrounding this technology has become a hot topic within the electric vehicle (EV) community. Some view it as a bold step toward democratizing performance, while others see it as an example of unnecessary technological excess. This shift also reflects a broader trend in the Chinese auto market, where consumers increasingly expect cutting-edge features even in family and commuter vehicles. Regardless of the perspective, BYD's move highlights its engineering expertise and confidence. By offering high-performance capabilities in models designed for everyday use, BYD is challenging traditional boundaries between power, price, and practicality. If successful, this approach could reshape consumer expectations, not only for premium buyers but also for anyone seeking an electric car that delivers both excitement and advanced technology. In another groundbreaking development, BYD has introduced a 1000-volt charging system that could redefine EV convenience. Promising a full charge in just 5 minutes, this system marks a significant leap beyond Tesla's Supercharger V3, which typically requires around 15 minutes for a comparable charge. This innovation goes beyond merely improving battery input rates. It boldly signals that ultra-fast charging is no longer a futuristic concept but a present-day reality. This announcement arrives at a pivotal moment when consumer demand is increasingly centered on practicality and charging speed, alongside driving range. It highlights BYD's ambition not only to lead in electric vehicle (EV) hardware but also to actively shape the future of charging infrastructure. By doing so, BYD is positioning itself as a direct challenger to Tesla and established performance brands like Porsche, which have traditionally set the benchmark for charging speed. The potential impact of this development is significant for a wide range of users, including urban commuters, taxi fleets, logistics operators, and road trip travelers. The ability to fully charge an EV in the same time it takes to grab a coffee removes one of the last major hurdles to widespread EV adoption. However, this breakthrough also brings important questions about the readiness of infrastructure. Can public charging networks and local power grids support the high voltage and current demands of such advanced systems on a large scale? If BYD's ecosystem is built from the ground up to support this new charging architecture, it could quickly distinguish the company in competitive markets, especially where fast charger turnover is critical. Reports suggest that BYD has already begun collaborating with utility providers and urban planners in key regions to deploy compatible charging stations, potentially creating an integrated ecosystem capable of growing and scaling in both urban and rural environments. Achieving this technical milestone could mark a significant shift in the EV landscape. BYD's approach requires more than just high-powered cables. It is expected that the company has leveraged its vertically integrated supply chain to develop specialized battery packs, advanced cooling systems, and silicon carbide power modules capable of safely handling extreme energy transfer while maintaining long-term performance. The company's in-house innovations, particularly its Blade battery, already provide enhanced thermal stability and fast charging capabilities, making it well-suited for a 1000-volt system. New thermal management techniques, such as direct refrigerant cooling, advanced thermal interface materials, and multipath heat dissipation, are likely to ensure safety and durability even under intense charging conditions. If proven effective for mass-market applications, this technology could disrupt the industry's current focus, which typically targets charging times of 10 to 15 minutes. Achieving a 5-minute charge would represent not just a technical milestone but a shift toward refueling paradigms akin to traditional gas stations. While much of the EV industry emphasizes software updates and self-driving features, BYD's innovation underscores progress rooted in infrastructure engineering and user experience improvement. This focus on technology could cement BYD's leadership not only in EV hardware but also in the broader electrification and efficiency landscape. BYD's ultra-fast charging system is designed to be compatible with both current and future vehicle models, including more affordable options such as the Chen L. This positions BYD for widespread adoption, aiming beyond niche markets. The key question now is whether other automakers, including Porsche, will quickly adapt or if BYD's first-mover advantage will allow it to redefine expectations for modern EV charging experiences. Regardless, BYD has undeniably raised the standard. As BYD continues to advance technologically, a more complex global race is unfolding where innovation intersects with geopolitical tensions. With BYD's rapid growth, the global electric vehicle landscape is increasingly shaped by political dynamics. While Tesla faces backlash over Elon Musk's controversial political ties, such as his support for Donald Trump's re-election campaign and associations with far-right groups in Europe, BYD has largely avoided political controversies. Instead, the Chinese automaker has established itself as a disciplined, tech-focused alternative, steadily expanding its international presence while maintaining a low political profile. This strategy is gaining importance in markets where political neutrality is seen as a valuable brand asset rather than a liability. BYD's branding emphasizes technology, sustainability, and innovation over political affiliations, which strengthens its global appeal. BYD appeals to both regulators and consumers who value stability in an increasingly polarized global environment. However, the company is not immune to geopolitical tensions. Rising trade frictions between China and Western economies have led to increased scrutiny and potential tariff threats, particularly in the United States and the European Union. Issues related to supply chain control, data privacy, and national security have prompted regulatory investigations and the prospect of significant policy shifts. In response, BYD has started relocating parts of its manufacturing operations overseas, planning to establish passenger car and battery factories in countries like Thailand, Brazil, and Hungary to localize production and reduce vulnerability to future trade barriers. The company's strategic expansion is supported by partnerships with regional governments and infrastructure providers, enabling BYD to build a strong foothold in markets with growing demand for electric vehicles, EVs, and relatively low political resistance. What distinguishes BYD in this politically charged landscape is its wide institutional backing and long-term vision. Notably, a significant stake is held by Warren Buffett's Berkshire Hathaway, which, despite being reduced from its peak, lends the company global credibility and helps it navigate political challenges more effectively than many competitors. Additionally, BYD is diversifying its approach by focusing not only on exporting vehicles but also on key related areas, further strengthening its position. BYD is strategically expanding its influence in the global electric vehicle (EV) ecosystem by broadening both its hardware offerings and technology licensing. Through technologies such as advanced battery systems, semiconductor components, and comprehensive transit solutions, the company aims to reduce its dependence on any single regional market. A prime example of this approach is the Blade battery, which is already being supplied to major automakers like Toyota. This positions BYD as more than just a vehicle manufacturer. It becomes a key contributor to the critical infrastructure supporting global EV adoption. Looking ahead, BYD's ambitions appear to be shifting from a market-by-market expansion to a broader strategy focused on reshaping the global EV supply chain. In the event of growing resistance to Chinese EVs in Western markets, the company may pivot its efforts toward BRICS nations, Latin America, or Africa, regions that have traditionally been underserved by Western automakers. Additionally, strategic joint ventures with legacy automakers or energy companies could enable BYD to co-develop infrastructure in areas where solo operations would be less viable. Ultimately, BYD is transforming from a domestic EV producer into a major geopolitical player in the future of mobility. With scalable platforms like the E-Series, intelligent technologies such as Yun-Nian, and cutting-edge innovations in powertrain systems, BYD is not only leading in innovation but also strategically positioning itself to shape the future of global transportation.